As your programs get longer, they tend to get harder to debug, so it's time to show you more professional tools for debugging. Since we're using Eclipse as our integrated development environment, IDE, I'll show you the tools that are available in Eclipse. However, every IDE has tools like these. When most students start to debug, they put system out print line statements in their code to see what's happening on a given line of code at a particular time. There are lots of problems with debugging programs this way. One is that it's slow. You have to put in the statement, run the program, remember to take it out. And if you make a mistake and take out an extra line of code when you remove the system out print line, then your program is broken again and you have to go back to debugging. To make matters worse, you probably think that the part of the program you just debugged isn't going to be the problem, and so you look elsewhere. If you leave all those system out print line debugging statements in your code, even if you comment them out, your code will be long and messy. So system out print line for debugging is a really bad idea. But there's another reason to learn to use debugging tools. When a professional programmer looks at code that's littered with system out print line statements, they'll think you don't know how to use your IDE effectively. For example, if you were interviewing for an internship and this showed up in your code sample, the company might think you weren't skilled enough to hire. If you want people, particularly employers, to treat you like a professional, you need to act like one. Learn to use your tools well. Remember, professionals get paid better. This advice applies to a lot of fields in addition to programming. When you debug code using an IDE, the compiler has to change how it stores the information in the code. We call this entering debugging mode. It's done in Eclipse by entering the debug perspective. The first time you do it, you have to select it from the Windows menu. Once you've used it, Eclipse will remember and keep a debug icon for you on the upper right corner of the window. The two features that Eclipse has that are most useful for debugging are called breakpoints and variables. Breakpoints let you choose when your program should stop, and variables let you see what each variable contains at the time the breakpoint stopped the program. To set a breakpoint, you click on the area to the left of the code in the center left panel of the screen. You'll see the breakpoint listed under the Breakpoints tab at the upper right of the screen. To run your code in debug mode, you choose the bug icon to the left of the green circle with the white triangle that's used to run your program without debugging. If you choose the Run button, like what we've been doing all along, the program will ignore your breakpoints and run as usual. This is handy when you're debugging because you can flip back and forth between programming and debugging easily. When your program encounters a breakpoint, it will stop running and let you see all of the variables that are in scope. These are shown in the Variables tab, next to the Breakpoints tab. You can click and scroll around to see exactly what's stored in your variables at that point in time. When you're finished looking around, you can exit the program with the red button or let it finish by clicking the green arrow to the left of the red button. After you've figured out what's in your data, sometimes you want to continue to execute your program one step at a time. This can be done by setting multiple breakpoints. The computer will stop every time it hits a breakpoint, no matter how many you place. To remove breakpoints, you click on them. Once you've finished debugging, you can return to your regular Java perspective by clicking the J button near the upper right. IDE tools are great for debugging routine mistakes, but sometimes programmers make mistakes that are hard to debug. For example, you can make some really bad mistakes with object references and object construction that are tough to find. Let me give you an example. ArrayList of string builder list equals new ArrayList string builder. String builder contents equals new string builder, two double quotes together. Int count equals 0, while count is less than 5. List.add of contents, count equals count plus 1. So, what happens when we do this? List.get of 0, .append, high in double quotes. If we print out the list, we'll see 5 copies of high. That is probably not what you were expecting. Or, if it is, you're doing really, really well programming. Congratulations. The problem here, if you haven't already figured it out, is that we've put the same string builder object reference into 5 different locations in the ArrayList list. This is very, very unlikely to be what we wanted to do. The debugger won't be able to help you figure this out much because it will show the 5 string builder objects that are empty, and that's just what you would expect. To make matters worse, this would work perfectly fine if we had used string instead of string builder. Since string objects are immutable, the fact that they're reused multiple times would be immaterial. This is a hard debugging problem. We need a more nuanced tool to help us analyze these situations. When I was a young programmer, I learned to use memory diagrams to help me understand how programs really worked. This is how I solve challenging debugging problems even now. Let's look at what happened in the loop above. The problem is now clear. When we changed the first string builder object, we changed all of them. Of course, we still have to figure out how to fix this problem. What we really want to do is have 5 string builder objects instead of 1. We do this by putting the string builder constructor in a loop. I'm going to do this by getting rid of the contents reference and creating anonymous string builder objects in the add method. If this makes you uneasy, you could do it in more steps. ArrayList string builder of list equals new ArrayList string builder. Int count equals 0, while count less than 5, list.add new string builder, double quotes right next to each other, count equals count plus 1. List.getZero.append hi in double quotes. Notice now the string builder constructor will be called 5 times, and we'll get 5 different objects. When we change the first one, remember it's the one at index 0, we won't change the other 4. These tools will make it possible for you to debug your programs more successfully. So now that we know how to fix programs, we might consider what makes a program good or bad. This question turns out to be a lot harder than you might think because it's highly dependent on context. When I was learning to program, computers were rare and expensive. My college only let me run my program 2 times a day. What my professor thought was the most important thing was having programs run fast and use little memory. And in that context, he was right. That was really important given the resource constraints. Now that computers are so much faster and memory is so much bigger, those may not be the most important things. What tends to be important now is often how easy the software is to fix and improve, called maintainability. That's why I nag you about including comments, using meaningful variable names, writing things in simple and powerful ways, and keeping your code neatly organized. But that isn't always true. If you're writing a program that predicts weather, speed is really important. No one needs to know whether it's going to rain today, tomorrow morning. This is a fairly common pattern in engineering, and programming is part of engineering. If I ask 100 students which car was best, I'd probably get at least 50 different answers. One student might like the one that drove fastest. Another student might like the one that was the most safe, and a third might like the one that used the least gasoline. There is no single car that's best. So when you use the word best with an engineer, they'll almost always ask you in what sense, because things in engineering, just like programming, tend to be trade-offs.